Hello. A few weeks ago we worked on this on my YouTube channel. It's a strange little tape recorder that uses a special kind of tape, so really you need this machine to play it back. Actually, if you remember, on that video I initially thought I was going to be getting a kind of tape recorder which used open reel tapes of 1/4 inch tape that has a rim drive, which means the tape is driven by the spools themselves rather than by a pinch roller, which most tape recorders have. I was quite pleased though that I actually got this. It's more interesting than the rim drive tape recorder. But I still do need a rim drive tape recorder, because the problem being that the tapes made on those won't play back at a consistent speed if you play them back on a normal tape recorder. I'm still been looking for a rim drive tape recorder from somewhere. Oh, I wonder what's on this. Okay, there's a pile of tapes here, many of which are supplied on these Kodak film spools, but they are sort of compatible with audio reels that they should be on. And the point is that because this is rotated rather than the tape being pulled along by a pinch roller, the recording speed on the tape is not constant as it is on a proper tape recorder. Oh dear, that's just fallen off. So you really have to play them back on the same kind of machine in order that the slowly changing speed of the recording on the physical tape is matched in the player. So let's have a look and see what's in this box. Right. So it's branded International. Don't know what kind of brand that really is. Play record. I might lock out the record switch. We don't know any accidents with that. Rewind, stop, forward. Not quite sure how you put it into play. Min, max, what? Volume? Don't know. Any other markings? No. Okay. And okay, we have a model number. That could be useful. And I think you can see the motor here, which is connected to both spools. And that, oh right, okay, so that switch, that's for fast forward and rewind, yes, connects the motor to directly to the spools. So there won't be a pinch roller in here. Let's prove that. Right, so no pinch roller, just a head. Oh, and that's the record play switch. Oh, I see. It flicks this across when it's in the record mode. And what I'm somewhat confused by, okay, you've got this felt pad which pushes on the head. But when you make a recording, how do you erase the old recording? There's no erase head. Oh, look, there's a permanent magnet there to do the erasing. Oh, what a nasty piece of work. Right, okay. This is really quite horrible, but you know, it's what we have to work with. And what's in here? How does that come off? Rust, lots of rust. Even more rust. So that's where it takes medium-sized flashlight cell. It says, what, C-size batteries? It's all bit corroded, and then some sort of headphone or microphone, and another battery. There's a PP3 battery, a 9-volt battery. Oh, that's the weirdest thing. So why would you have 3 volts and 9 volts? I mean, that's got to be lousy circuit design, hasn't it? So maybe 3 volts drives the motor and 9 volts drives electronics. But you know, you've got to be customer focused. You've got to think about what your customer wants, and your customer doesn't want to be buying different sized batteries. So that's horrible. Might have to sort of redesign that somehow with some modern electronics. So that's a microphone. I think that's a microphone, but it's nasty. So that would presumably connect to that socket there. All right, and there's grot in here. Oh look, Japan. It's made in Japan? Oh dear. Well, Japan's come a long way since then. Should we take this battery out, because this is going to be in horrible condition. Get rid of that. More junk. It doesn't even say PP3. For some reason they didn't even call it a PP3. They called it a something else. 006P I think they've called it. So now we can see what we have here. I'm going to take these screws out and hopefully we can get it apart and see how it works inside. Right, I'll also set you up so you can get a better view of it once I've cleaned all this grot. Okay, this has got to be one of the nastier pieces of equipment to ever visit the Video 99 workbench. Is that a speaker? So we don't have to use the earphone connector. Obviously, if we get this working, we'll be using the earphone connector for connecting to a digital audio recorder. Interestingly, it looks like it picks off 1.5 volts as well. So we've got... Oh, we've got actually, look at the battery layout. Are these batteries in parallel? 1.5 volts with... on this blue wire. Sorry. So the battery negative goes to the blue wire for both batteries. And then battery positive should go to a middle terminal here. What a weird arrangement. So it's not 3 volts, it's 1.5 volts it takes from this. And that's going to this spring. They've used a spring? No, that's not a spring, is it? There's something going on there. That's some sort of resistor, I think, is the way that's being used. What a strange circuit. We have our amplifier here, which has, I think, germanium transistors. Can't quite tell from the design of them. And then the 9 volts, negative side is to the switch and positive side to the electronics. This is the weirdest thing. So, presumably in stop, that's disconnected. Presumably. I wonder if we can get any schematics from this. That switch is branded Matsushita, so it's Panasonic. And this switch arrangement seems to rock the motor from one side to the other of these tape spools. But there's a pulley on one end and not on the other. Though that might just mean that the pulley's fallen off, which would be a bit catastrophic, wouldn't it? But that might be gearing. When it's not in fast forward... Oh, I don't think it does have fast forward. I don't think it has fast forward. I think it has just forward and rewind. Okay. So in the rewind position, that pulley is connected to the supply spool and the motor is spinning, so that works. And then in the stop position, it's not connected to anything. And maybe this brake is in operation then, not sure, possibly. And then in forward, that shaft connects to this motor, to this pulley, not via any extra pulley. So that's the way it does its gearing. So that's slower, and that just pulls on the take-up spool in that direction. And surprisingly, that actually seems to work. So our biggest problem is how to power this, because it's complicated and confusing. But the 1.5 volts positive seems to go to the motor, and the motor negative goes over here to the switch And I think the other side of that goes to this spring arrangement. Alright. And min and max, what's that? Is that volume? It looks like it is. The wires to that go to the amplifier board, so that's not speed, it's just volume. Alright, let's see if we can find some more information on it based on the model number. Right, it appears that this heap of junk was sold under various different brand names and with some modifications. And there was a version with a remote control socket which it doesn't have, which was made by Aiwa. So that probably is the original manufacturer. It certainly seems to have a similar arrangement here. So you've got a PP3 and 1.5 volts for the motor. There seems to be nothing actually sort of wrong with what we have here apart from the disintegrating battery hatch. Provided these components are still in working order, it might actually work. So I'm inclined to connect a 9 volt and a 1.5 volt power source and just see what we get. Well, I've got a dual output power supply beside me here, so I'm going to do that. Quite scared, but I'm going to do that and see if it sort of tries to work. Okay, I've hooked this up, so we have 9 volts available here and 1.5 volts available here, both with some current limits. Let's switch on the power supply and see what happens. Right, so first I'll try rewind. Oh. I may not have a connection because I'm not getting any current draw at all on the 1.5 volt rail, so let's investigate that. Okay, my wire for the parallel battery has just fallen off, so never mind that. So I have 1.5 volts available here and 9 volts available here, I hope, from my power supply. So let's just see if anything happens. Switch the power supply on and select rewind. Motor ran for a moment. The switch is playing up. Okay, let's clean the switches and try again. Okay, try rewind. Yep. And forwards. Okay. So we just need the amplifier to work. And you'll notice, very simple amplifier. There's no AC bias involved in this, so the recordings are going to be primitive. Okay, we're ready for first attempt at a playback.
In particular, I'd like to say thank you to the lifeboat service in Birmingham and also the Air Sea Rescue Organization from Leconfield who kindly helped us when our captain was taken ill and when we had a small accident to one of our crew members. Furthermore, I'd like to say a big thank you to all our sea crew, both past and
Better than I expected. The tape is sticky, look. Can you see how the tape is sticking itself together? Okay, it's working. There's massive wear and flutter. But at least in part that's caused by the sticky tape, I think. So if we can just run this tape through, or maybe put it through a baking process and make it less sticky, then that might help. And it will be double-sided, so I'll be able to flip it over and play the other side. So I'll just leave that running through for a minute. Then I need to think about how I'm going to do this in a sort of volume. You know, if I need to be able to record people's tapes for them, what would I do? Because I don't want to be hooking up all this power supply nonsense every time. So I need to look at whether I could come up with a way of powering it on 9 volts, and that 9 volts deriving the 1.5 volts for the motor. That depends on the switching, because at the moment the power supply has the 2 rails isolated. It might be that if I do that, I will defeat the isolation and cause a problem. So I need to look at the exact wiring. Just for your information, the current draw on the amplifier is low, just a few milliamps, so low that my power supply is not reading it. And the current draw on the motor at the moment is 100 milliamps at 1.5 volts. Right, let's think about what I could do here. When it's in forward mode, we've got minus going to minus B there, and plus going to plus E there for the amplifier. But what about the 1.5 volts? Well, positive goes to ground. It's not clear if these are associated with the ground. Not clear. And minus goes to the motor. There may be a remote control jack. Well, there is one for the Aiwa version, not for this. So the wiring here is going to be subtly different. Let's just assume that that's shorted out. It'll be connected via this, which will be shorted. Ah, look. To ground. When it's in the forward position, I think, it's a bit hard to work this out, but I think the battery's got positive to ground, and then the motor negative terminal is also connected to ground. So the motor runs with 1.5 volts. So if I was to take a 1.5 volt regulator from the 9 volt rail here, I'd have to think carefully about what's connected to what, because I need the 1.5 volts positive side to be grounded. So would I need a negative 1.5 volt regulator? What's odd is it's playing very much faster than the original tape was recorded at now. I'm going to put this tape on a normal tape recorder and see how it responds. I am beginning to wonder if this particular tape was recorded on this particular machine at all. So I have been working on my customer tapes. None of them actually required this machine, but I still want to have this machine running for the purposes of any tapes that have been recorded on a rim drive tape recorder. Sometimes they're in a cassette or sort of a cartridge thing, but still you can take the spools out, mount them on here, and I believe that any rim drive tape recorder like this will play those tapes back either at the correct speed or at least a fixed speed error from the correct speed. So it's still worth fixing this thing or making it usable. Now, I don't like this power arrangement. So you've got the PP3 battery and 1.5 volts. It's totally impractical for me to use it in that way. So looking at the power supply settings, we have 9 volts here, positive over here, and 1.5 volts here, positive to chassis. But if we follow this plus 9 volt, it goes to plus E and works its way through the amplifier and then comes down here to chassis. So I'm right, I think, that the plus battery terminals are connected together. So let's test that theory. And if I'm right, then I need a plus 1.5 volt regulator. Where am I going to get that from? So let's just get this in continuity mode. So I'm thinking that the plus terminal here is connected to the plus terminal here. I'll disconnect one of these from the power supply to isolate it. So that's the 1.5 volt battery. Very manky old terminal. Let's make sure I'm making good contact with that. Oh dear. Right, making contact with that. And then, aha! And is it 0 ohms? Well, yes, a fraction of an ohm. So, I'm right that A negative regulator is what I need if I'm going to run them both off the same 9-volt power supply. Now I don't have such a thing, not a 3-volt one anyway, a 1.5-volt one I should say. So I'm going to have to stop this here and find some such regulator. I may have to get a variable one. I don't know if anyone does a 1.5-volt regulator. I could get away with say 2 volts and drop a bit with a diode maybe, or I don't want to have too many diodes. And if I had a 7905 regulator, probably got those in stock, but losing all the voltage between 5 right the way down to 1.5 I think is going to be unreliable using just the forward bias of diodes to do that, because as well as the 0.6 volts nominal voltage on the diodes, there's also going to be a forward resistive component, and so it's not going to be very well regulated. That's my thought on it. So let's see if we can think about a supply arrangement for this. I might go with this ugly idea of using lots of diodes. So I have a 7905 here. The ground, of course, is plus 9 volts, which is what I was using to drive this a moment ago. And then input is 0 volts because it's a negative regulator. So I should have 9 volts on the input. Good enough. And then the output from this regulator should be 5 volts. Good. And then I should lose voltage along these diodes. And I've got a resistor here, which I calculated is roughly equivalent to the motor. So I should get down towards something approaching 1.5 volts along these diodes. And I was having a bit of trouble getting the right voltage and experimented with different diodes because 1.8 is a bit high. And then used this great big diode here with a lower voltage drop. And then at the end we have 1.3 volts, which is probably close enough and probably quite close to the actual voltage you'd get off a battery when it's been set on this motor for a while. I might experiment some more to see if I can fine tweak that voltage, get it just a little bit higher. But you can see that the general principle is working. What if I take out one of these diodes, these 1N400 something diodes, and drop in one of these? It's a SR5100. So let's drop that in. Notice which way around the diode's face, of course. The current is flowing into the regulator. These are a little bit big for my breadboard. Okay, with that set of diodes I'm getting 1.7 volts. I think that is definitely going to be close enough to 1.5 volts. So we're going to run with that, I think. I can test this next on the motor and make sure that everything does work. Right, so if I've done this correctly, and there's many things could go wrong here, I've left the resistor in circuit for a moment to give us a load, though I may take that out later, but right now. So we should have about 1.7 volts or so going to this point here. This is 1.7 volts negative relative to the chassis. And this is the 9 volt supply, which is also connected to the regulator circuit as well as to the electronics in here. And I didn't bother connecting the plus terminal wire here because it's common anyway with this connection here. So if I'm lucky, when I switch my 9 volt supply on, right, I'm seeing a bit of current draw caused by this resistor. Now if I select forward, and I should be able to get some buzz out the speaker if I turn the volume high enough. Yeah. Okay, so we could build that onto a small board and insert it into here and then give it a connector there to connect to a 9 volt supply, and we've got something we can actually use then. Here's my circuit now on a little bit of strip board. Why do I always use insufficient strip board? Anyway, it's on there and it's got a 100 ohm load resistor on there just so it's got some load. So now if I switch this to forward and we get sound, Yeah. And rewind. Good. So now I could build that in and sort out a power connector, and we're more or less there. Okay, after a bit of soldering, so I've got my regulator here. It's got input, which is shared from the 9-volt input here, and that is also connected to this. So I no longer need to use a PP3 battery. We can just have 9-volt center positive on this, and I will label it up shortly. Then the output of my 1.5-volt regulator goes to the battery terminals for the 1.5-volt batteries, which were connected in parallel before. And I've connected both the positive, which is common anyway, because I don't want currents flowing along this return path from the motor. So I've connected it up just as per the original battery arrangement. I've also added an extra decoupling capacitor there of about 680 microfarads just to smooth the flow, and I also have a 0.1 microfarad decoupling on the regulator. So hopefully that'll all work fairly well. So now I've just got to put it back into the case and secure a location for the regulator. This is not going to get hot. It's only going to be passing 100 or so milliamps, so that regulator won't need any extra cooling. Right, we can test it now on a mains adapter. In fact, I didn't need to have fitted this if I was using this particular mains adapter, because I could have just gone straight onto the 9-volt terminals with that, but that's a bit clunky and might not work in every situation. So I'm going straight to this. Actually, I've set this to 7.5 volts because that I think is a little generous and is closer to 9 than 7.5. So I'll power it up and just check that things seem to work. Forward is working. I'm having a bit of trouble with rewind. Catching up on something. Okay, let's take the screws out and have a look and see what's wrong. Okay, now, might be just catching up on here somewhere. Let's give it a quick test with a tape. What happened? It's playing better than that before. Okay, that's now working. I'm almost tempted to make a recording, but given the state of the microphone connector, maybe not.
Have been reluctant to be delineated or even to use the correct place names.
It actually works quite well. And rewind. Not terribly fast, but it does it. I'm a great believer in labelling everything, including my modification. And I'll pack the schematics in with it, albeit that certain components are not quite right. It's close enough. And for connecting to a digital audio recorder, we have the earphone jack. I already have cables suitable for connecting that up. So that's the result. I wonder how old that battery is. Ajax dry battery for transistor. It says Empire made. Wow. Well, I hope you've enjoyed us working on this whole thing. Now, there are a few reasons this might not be terribly useful. One is that it uses the largest spool size it takes is this, and I don't know if any other rim drive tape recorders use larger spools. If so, they wouldn't fit this, so they wouldn't play on it. You could also argue it might be possible to create some kind of filter or effect with Audacity, which allows you to do a speed change with a slope over time. And if such a thing existed, that would be potentially better than using this, because you play the tape back on a conventional tape recorder and apply that curve to the speed correction. You wouldn't necessarily know if you've got it right unless there was music or something like that that you could compare it to. But then you wouldn't necessarily know if this is playing at the right speed either. So that might be a better solution to do it in software. But nonetheless, it's nice to have recovered this whole thing. Now, it's made by Aiwa apparently, or at least Aiwa sold them, but we don't really know. But it says made in Japan. And I guess it goes back to the days that Japanese equipment wasn't necessarily the best, because it's not the way to build a tape recorder. Right, I hope you've enjoyed that. I'll do plenty more content on audio and video technology in the near future. Bye for now.